Look down at your hand for a second. Whatever shade it is, pale enough to catch a sunburn from a cloudy day, or dark enough to shrug off hours of direct sun, that color didn't come from nowhere. It's the result of one of the longest, strangest survival stories in the history of our species. And here's the part that surprises most people. It wasn't random. It wasn't an accident. It was a slow, brutal negotiation between your ancestors and the sun was not playing fair. If you trace the human family tree all the way back, every single one of your ancestors, no matter where you're from today, had dark skin. Not most of them, all of them. Around 300,000 years ago, when Homo sapiens first appeared in Africa, the entire species was dark-skinned. There were no pale populations anywhere on the planet. The idea of light skin simply didn't exist yet in humans. So somewhere along the way, something happened, something powerful enough to reshape the physical appearance of entire populations across multiple continents. To understand what, you need to understand what skin is actually doing for you. Most people treat it like packaging, the wrapping your organs came in. But skin is your largest organ, and one of its most important jobs is defending you against UV radiation, the invisible energy the sun fires at Earth constantly. UV light damages DNA, it causes mutations, and enough of the wrong mutations lead to skin cancer. This is where melanin comes in, the pigment responsible for skin color. Melanin is, in the most literal biological sense, sunscreen, a built-in, always-on UV filter. More melanin means darker skin, and darker skin means better protection for the DNA sitting just beneath the surface. In equatorial Africa, under some of the most intense sunlight on the planet, evolution selected hard for dark skin. More melanin meant less cancer risk, longer lives, and more successful reproduction. Natural selection doesn't care about appearance. It runs one calculation over and over. Does this trait help you survive long enough to have children? In Africa, dark skin was an emphatic yes, every single generation. But there's a second, less obvious reason dark skin mattered just as much. UV radiation doesn't just damage skin cells, it also destroys a molecule called folate, a form of vitamin B9 that's essential for early pregnancy. Folate is critical for the development of the neural tube, the structure that becomes the brain and spinal cord. Without enough of it in the first few weeks of pregnancy, often before a woman even knows she's pregnant, that structure can fail to close properly, leading to severe developmental problems or miscarriage. In a sun-drenched environment with no clothing and no shelter, UV exposure was constant, and lighter skin meant more UV reaching the bloodstream, meaning more folate destroyed. So dark skin in Africa wasn't just useful, it was doing two critical jobs at once, protecting DNA and protecting pregnancy. Given all that, dark skin sounds like a flawless design, so why did it change at all? Between roughly 70 and 100,000 years ago, groups of Homo sapiens slowly began leaving Africa, spreading gradually through the Middle East, into Europe, across Asia, eventually reaching the Americas. And as populations moved north, something fundamental about their environment shifted. Not the sun itself, but the angle it hit the Earth. At higher latitudes, sunlight passes through more atmosphere. UV radiation weakens, winters grow long and dark, and skies stay overcast for months at a time. Suddenly, the same dark skin that was essential protection in Africa became a liability, not because of cancer, since UV was now weak, but because of something else entirely: vitamin D. Vitamin D is produced in your skin when UVB radiation hits a specific compound just beneath the surface. Your skin is essentially a solar panel, converting sunlight into a molecule your body absolutely cannot function without. Vitamin D regulates calcium absorption, and without it, bones don't mineralize properly. In children, severe deficiency causes rickets, softening and deforming bones. In women, it can soften pelvic bones so severely that childbirth becomes extraordinarily dangerous. Now picture a dark-skinned population living in northern Europe tens of thousands of years ago. Their melanin, so effective at blocking UV in Africa, was now also blocking the limited UV they desperately needed to make vitamin D. Skin can't distinguish between UV that's dangerous and UV that's necessary. It just blocks. So vitamin D production dropped, bones weakened, and reproductive outcomes worsened. In a pre-industrial world with no supplements and no fortified food, this wasn't a minor disadvantage. It was a slow-moving crisis stretched across generations. And so evolution, patient and indifferent as ever, started favoring mutations that reduced melanin production, because slightly lighter skin meant slightly more vitamin D, slightly stronger bones, and slightly better odds of survival. For a long time, scientists assumed this shift happened slowly and steadily as people spread north. Recent ancient DNA analysis completely upended that idea. The most famous example is a specimen called Cheddar Man, who lived in what is now Britain around 10,000 years ago. DNA analysis published in 2018 revealed he likely had dark to medium dark skin, dark curly hair, and blue eyes, a combination that looks almost contradictory today since we associate blue eyes with very fair skin. But 10,000 years ago, that link simply hadn't formed yet. The extremely fair skin associated with northwestern Europe today appears to have spread widely only in the last 6,000 to 8,000 years. In the full 300,000-year history of our species, that's less than the final 3%. So what happened 6,000 to 8,000 years ago to suddenly accelerate this so dramatically? The Neolithic Revolution, the shift from hunting and gathering to farming. Hunter-gatherers ate a varied diet naturally rich in vitamin D, fatty fish, organ meats, shellfish. Early farming populations, by contrast, ate mostly cereal grains, and their dietary vitamin D intake collapsed almost overnight in evolutionary terms. Suddenly, people who'd been getting by on modest skin-based vitamin D synthesis supplemented by their diet were now almost entirely dependent on their skin alone. If that skin was still fairly dark, it simply wasn't enough. On top of that, farming communities were larger, denser, and more interconnected than scattered hunter-gatherer bands, and population density dramatically speeds up how fast a beneficial mutation spreads through a gene pool. The combination, a collapsed dietary vitamin D source plus dense connected populations, hit the fast-forward button on European depigmentation. Here's something that genuinely surprises most people. Skin color isn't controlled by a single gene. There's no simple dark skin versus light skin switch. It's a polygenic trait shaped by dozens of genes working together. And remarkably, populations that independently evolved lighter skin didn't all use the same genes to do it. East Asians and Europeans both evolved significantly lighter skin than equatorial Africans, but largely through different genetic pathways. This is called convergent evolution, the same solution discovered independently more than once by separate populations facing the same problem. When evolution reinvents something from scratch multiple times, that's about as strong a signal as biology gives you that the trait really truly mattered. So here's the full picture. Skin color, something that's been used throughout history to sort and divide people, is at its biological core a UV calibration system. Your body's best inherited estimate of how much sun protection versus sun absorption you need based on where your ancestors happen to live. Light skin isn't better in any absolute sense. In equatorial regions, it's actively dangerous. Dark skin isn't primitive or lesser. It's the original human condition, the baseline every other variation branched from.
The same sun that pushed some populations toward more melanin pushed other populations toward less for entirely different survival reasons. The sun never picked sides. It simply radiated indifferently and let evolution work out the rest. Every shade of human skin alive today traces back to the same original population standing under the African sun, slowly spreading across an unpredictable planet, carrying in their skin a quiet, ongoing record of exactly where their descendants ended up.